Did you know that the first internal combustion engine was actually designed in the 19th century? Yet, it's the 21st century that has truly revolutionized it. The internal combustion engine, a marvel of mechanical engineering, has been around for nearly 2 centuries. Its basic principle, converting chemical energy into mechanical energy, has remained fundamentally unchanged. However, the way we implement and optimize this process has undergone a dramatic transformation, particularly since the turn of the millennium. Engines of this type are omnipresent in our lives. They power our cars, our boats, and even our power generators. They're the beating heart of our modern world, turning the wheels of progress every day. Yet, many of us don't realize just how much these engines have evolved over the years, becoming more efficient, powerful, and environmentally friendly. Now let's journey through time from the year 2000 and see how the internal combustion engine has transformed. As the new millennium dawned, engineers were seeking ways to make engines more efficient and environment-friendly. The year 2000 was a turning point. Indeed, the turn of the century heralded a wave of innovation that would forever change the landscape of engine technology. One of the most significant advancements of this time was the introduction of variable valve timing, or VVT for short. This ingenious technology was a game changer, promising to deliver more power, better fuel efficiency, and lower emissions. So, what is variable valve timing, and why was it such a big deal? Well, in the simplest terms, variable valve timing is a system that allows an engine to adjust the timing of its intake and exhaust valves dynamically, according to the engine's needs at any given moment. This is a departure from traditional systems, where the timing of the valves was fixed and couldn't be changed. Now, let's delve a bit deeper. In an internal combustion engine, the intake and exhaust valves play a crucial role. They open and close to allow air and fuel into the engine and to expel exhaust gases. The timing of these operations is critical for the engine's performance, fuel economy, and emissions. With variable valve timing, the engine can optimize the timing of these operations based on its current speed, load, and other conditions. This flexibility allows the engine to run more efficiently, delivering more power when needed and conserving fuel when power isn't required. Moreover, by optimizing the opening and closing of the valves, variable valve timing also helps to reduce the engine's emissions, making it more environmentally friendly. So there you have it. The introduction of variable valve timing at the turn of the century marked a significant leap forward in engine technology, setting the stage for the advancements that were to come. It offered a solution to the age-old trade-off between power, fuel efficiency, and emissions, and paved the way for a new era of more sophisticated, more efficient, and cleaner engines. Variable valve timing was just the beginning of a new era of innovation in engine technology. The mid-2000s brought us an innovation that changed the game entirely, the hybrid engine. This was a breakthrough that took the industry by storm, combining the power of internal combustion with the efficiency of electric motors. Suddenly, the world was presented with a solution that offered the best of both worlds. The hybrid engine was a milestone that marked a new era in transportation. It addressed two of the most pressing issues in the automotive industry: fuel efficiency and emissions. By utilizing a dual-power system, hybrids could switch between or combine the use of traditional fuel and electric power. This meant fewer stops at the gas station and a significant reduction in harmful emissions. In essence, it was a win-win for both consumers and the environment. Major companies were quick to recognize the potential of this groundbreaking technology. Toyota, for instance, pioneered the hybrid revolution with its Prius model. This was not just a car. It was a statement that technology could be harnessed to create a more sustainable future. Honda, Ford, and General Motors soon followed suit, each introducing their own versions of hybrid vehicles. But the hybrid engine was more than just a technological innovation. It was a catalyst for change. It challenged the status quo and sparked a global conversation about sustainability. It made us reconsider our relationship with the environment and pushed us to strive for a greener future. The hybrid engine also marked a shift in consumer behavior. As more and more people began to understand the benefits of hybrid technology, demand skyrocketed. Today, hybrids are no longer a novelty. They are a mainstream choice for millions of drivers around the world. The hybrid engine was a big leap towards sustainability, but the journey didn't stop there. It was a stepping stone that paved the way for even more advancements in engine technology. And as we move forward, we continue to innovate, always looking for ways to make our engines more efficient, more powerful, and more sustainable. As we moved into the 2010s, turbochargers started to become a common feature in many vehicles. These dynamic devices, previously associated primarily with high-performance vehicles, began to find a home under the hoods of even the most common cars on the road. So, what exactly is a turbocharger and how does it work? Well, in the simplest terms, a turbocharger is a device that forces more air into the engine's combustion chamber, allowing it to burn more fuel and produce more power. It's a bit like blowing on a campfire to make it burn hotter and brighter. The turbocharger uses the engine's exhaust gases to spin a turbine, which in turn drives a compressor that pushes more air into the engine. It's an elegant solution to the age-old problem of how to get more power out of an engine without making it bigger. And that brings us to the trend of engine downsizing. As concerns about fuel economy and emissions grew, car manufacturers began to look for ways to make engines smaller without sacrificing power. The turbocharger proved to be the perfect tool for this task. By allowing a smaller engine to produce the same power as a larger one, turbochargers made it possible to have vehicles that were just as fast and powerful, but with better fuel economy and lower emissions. But like any technology, turbochargers aren't without their challenges. They can add complexity to an engine, and if they fail, they can be expensive to replace. However, the benefits they bring in terms of power and efficiency have made them a key component of modern engine design. Turbochargers brought power and efficiency to smaller engines, marking a significant milestone in the evolution of the internal combustion engine. As we continue to push the boundaries of what's possible with internal combustion, it's clear that turbochargers will continue to play a vital role in the story of the engine. From 2020 onwards, the focus has been on making engines smarter and cleaner. The internal combustion engine, a marvel of mechanical engineering, has not been impervious to the tide of technological advancements. A significant trend that has emerged in the recent years is engine electrification. There's a growing push towards integrating electric components into traditional internal combustion engines. This doesn't just mean hybrid engines anymore, but engines that can switch between electric and fuel modes, offering the best of both worlds. By combining the immediate torque of electric motors with the long-range capabilities of fuel engines, these electrified engines are redefining efficiency and performance. Next in line is the advent of smart engines. These engines are equipped with sensors and control systems that continuously monitor and adjust engine parameters for optimal performance. They can adapt to different driving conditions, optimize fuel consumption, and even carry out self-diagnostics to identify potential issues before they turn into major problems. Smart engines are essentially bringing the power of the Internet of Things to the realm of mechanical engineering. Another area of focus is the use of artificial intelligence. AI is being used to optimize engine design, predict performance, and enhance fuel efficiency. It's not just about building more powerful engines anymore, but about creating intelligent engines that can learn, adapt, and improve on their own. But perhaps the most crucial aspect of this era is the push towards cleaner and more efficient engines. With environmental concerns at the forefront, engineers are striving to reduce emissions and improve fuel efficiency. From incorporating renewable biofuels to developing advanced catalytic converters, the race is on to create engines that are not just powerful and smart, but also environmentally friendly. As we stand here today, we can only imagine what the future holds for the internal combustion engine. The journey thus far has been incredible, and with the rapid pace of technological advancements, the possibilities for the future seem infinite. From the dawn of the new millennium to the present day, the internal combustion engine has undergone an incredible evolution. Let's take a quick journey back. We began with the turn-of-the-century advancements, where technology brought forth an era of fuel injection and advanced engine designs. Then we saw the rise of hybrid technology, a fusion of electric and combustion that changed the game. This was followed by the era of turbochargers, pushing efficiency and power to new heights. Fast forward to today, we're witnessing a blend of all these advancements, creating engines that are more efficient, powerful, and sustainable than ever before. But it doesn't end here. The constant drive for innovation continues to push the boundaries, shaping the future of the internal combustion engine. In the span of just a few decades, the internal combustion engine has transformed dramatically. Yet, one thing remains certain: the journey of evolution is far from over.